Hello everybody, and welcome to this technology preview of SMILA 1.0. My name is Igor Novakovic. I work for a company called Attest Europe, and among other things, I'm also responsible for co-leading our open source initiative called SMILA. In today's technology preview, we'll take a closer look at the major new feature called self-scaling ETL, and this feature will be introduced in SMILA's upcoming graduation release with the version 1.0. So here is the short overview of the key points which I will address now. First, we'll talk about what actually self-scaling ETL is and why one should need it. Then I will give you a short overview of the changes to the ETL architecture itself. And on the last part, we will take a closer look at the timeline so you get a better impression about when this feature and the other parts will be available to you. Of course, if you have some questions, we will have some time at the end to answer them. So what is actually self-scaling ETL and why do I or someone else need it? The current situation in ETL is that it requires the manual partition of the data source. The crawler and agents do have a separate life cycle, and due all of this, we have a hardware or poor hardware utilization, so to say, which of course negatively affects the performance, and due to lots of manual work, due to operation and configuration, the administration impact is quite high. So ETL stands for extract, transform, and load, and the focus of this technology preview will be today on or extracting data from a data source. So this is what we try to address by enhancing our current ETL concept. And the new one that we introduced, or we will introduce in the upcoming release, we call self-scaling. So why is self-scaling? Well, what's the big deal about it? Well, first of all, you don't have to partition your data source manually anymore. This is being done by the crawler itself. It automatically partitions the data source. So first thing that it's really quite good, I think, if you are administrating the whole system. Secondly, the crawlers do not, and other components do not have any more separate life cycle, but they are very tightly integrated to the job management, or new framework which we introduced in the previous release of SMILA 0.9. So due to this symbiosis, so to say, with the job management, we have optimal, or let's say much better hardware utilization. The performance has been increased dramatically. And of course, the administration is much simpler now. So the current ETL situation can be observed in the upper left part of this architecture overview. And you can see immediately that there is a clear separation of components responsible for processing information and the one for getting them. You see that the crawler is actually running in its separate framework. It's being managed by the connectivity component, and it's, so to say, somehow outside of the system. With the new or upcoming release 1.0, we wanted to change the situation, and this is how the new architecture will look like in upcoming release, where you can see in the upper left part, the crawler is now being migrated, and all of its parts has been migrated into the job framework itself, and is being actually handled just as a normal job or asynchronous workflow. So if we take now a closer look to what is going on really in this self-scaling ETL, we can see that first of all, the ETL has got its own workflow. We call it a crawling workflow, which is actually a synchronous workflow with a special configuration. And that now this whole crawling, fetching, and pushing process has been separated in several components. With a prefix DS, you can note that each of those components is actually data source specific. So the crawler there will be one implementation, for example, for crawling a web server. So you would have in this place the web crawler. If you are crawling the file system, then you will have in this place the file system crawler. The same goes for the fetcher. This is a component which is also dependent of the data source, and a compound extractor. The other components, delta checker, delta service, update pusher, and bulk builder, are independent of the, so to say, of the data source that you are crawling, and can be reused, of course, for different data source. So this crawling workflow is being triggered, or is being run, so to say, by a job, which has the parameter set run once, which means that after the data source has been crawled, the job stops immediately. It doesn't run forever, so to say, and there is no manual interaction with this job needed to end it. The first information, the part information that this workload gets comes actually from the job parameter itself, and usually that could be some kind of starting point in a data source. So data source crawler gets actually a seed, for example, from the job itself, and knows, okay, this is my starting point, this is the point where I need to start my crawl. So the first thing it does, it tries to fetch some records with their metadata, and of course to produce new record IDs, which should be then again crawled from the data source. Therefore, we have two different buckets. The one is generally called, represented here, metadata, and the second one is to crawl. Metadata gets all the crawled records with their metadata, and to crawl is just bucket where we have the list of IDs, the records ID that needs to be crawled, so to say. So crawler is actually creating or getting the metadata from data source, but also creating the tasks for another parallel running data crawler. And the good thing is that all of these buckets, metadata and to crawl, are spread across the framework, across the cluster, so that the other instances of the crawler can work on them. And this is where the parallelization actually takes part when it comes to crawling the data source. Data source crawler has also the possibility to mark the sources that have been visited in this crawling workflow, and therefore there is a special store, or so to say special service which can be also integrated in the data crawler itself with the links, which takes care of crawling and, of course, processing of one resource just one time. So, for example, if you are crawling a web server, you know that there are several web pages represented on a different pages. So if you don't keep the track of the crawled pages, you would actually crawl the same page several times, which is something that we don't want to do. We have to, or we want to optimize this process. So we keep the track of visit links so that we can only crawl one resource once. So after the crawler has done its work and put some records with a metadata in a metadata bucket, another component called delta checker comes in place, which then checks if this resource, or in our case record, has been changed since the last execution of the crawling job or the crawling workflow. Why we did it? The answer is quite simple. We don't want to reprocess the records that have been changed since the last crawling work. So we have to do some kind of filtering, and this filtering is being done by the data checker. in the way that it talks to Delta service, which keeps track of the hash sums, for example, of the records, and gives the Delta checker information if the record has been changed. So the Delta checker actually filters out the metadata bucket and only pushes in the new bucket of the new and updated metadata the records that have really been changed since the last crawling workflow execution. The next component, which is data source fetcher. Here again, the note is this component should be implemented for different data sources because it can't be generic. This component either fetches the content of the record if the crawler haven't done this already, or it fills a new bucket, which we call compounds, and so to say, gives another task or creates a task for a data source compound extractor, which then downloads this compound, extracts it, and creates a new record, which are then being pushed or persisted in the records with content bucket. This can, of course, be done recursively, so that compound extractor, for example, while expanding a zip archive, can extract all of the records contained in this zip archive if it contains another different zip archives in itself. And at the end, where we have the filter out records, only the new and the updated with their contents, we are ready actually to push those records to a processing workflow, and the gate for it is the so-called bulk builder. But before we do that, we would also like to set the updated flag to the record that we are pushing, so the Delta service will know for the next crawling job execution which records have been processed or not. Also, this is important if we would like to delete all the records that haven't been found in the data source anymore. And this can be only done if we can query the data service about the records which haven't been updated, and therefore create a new Delta query, so to say, and push it to the bulk builder. So after taking this close look at the self-scaling ETL, we can point out the advantages of the self-scaling ETL. The first one, of course, there is no separation of the execution framework. We are now dealing with those components as a complete normal workers that are operating within our job management. Very important thing for the integrators or programmers writing components from SMILA, there is now no difference in programming a crawler or a processing module, because the same programming model has been used, the configuration is completely the same, and of course the lifecycle of this component is completely the same. The same goes for monitoring and control of those components. They are, like I said, just normal workers in job management framework, so the same APIs could be used for monitoring and controlling them. As stated before, the performance has been increased dramatically through inherent asynchronicity and parallelization, since now there is no need of manual, so to say, multiple instantiation of the components. The whole thing about parallelization has been done by the job management framework. Of course, since we have a built-in fault tolerancy in the job management, you can get it, or you get it for free now, also while crawling a web or another data source, just by the fact that these components are running in the same framework. The timeline. We are working very hard to put this release in public to publish it. And currently, we plan to release it in the first week of February 2012. Nightly builds, which are every day available in our website, are quite stable. So if you would like to give a shot and try it, you can do it. So there will be no, so to say, or there are no critical issues known. So you can easily try it and for example, try to migrate the components that you have to the new version. Currently, we implemented 2 use cases. The first one is web crawling, and the second one is file system crawling. For these use cases, we also provided a rudimentary implementation of web and file system crawler worker. This is something that needs to be expanded and will be done in future and upcoming version of SMILA. Still, the old ETL framework is there. So if you fear of not being able to migrate that soon, you can use the old file, web, and ODBC crawler in your projects too. Documentation has been provided. The slides that I've showed you are located on our wiki page under the documentation and importing section. And the APIs that we currently provide are quite stable. We plan to provide 2 new APIs, 2 management APIs. One is for delta indexing, and the one is for pipelet monitoring, which is quite exciting, so that we can separate ourselves from JMX as a protocol for monitoring operation and completely switch to the REST APIs when it comes to operation management and monitoring. The last feature that we would like to implement is also the compound handling. You see it in the previous slides. Compound handler is actually a concept there, but there is still no implementation of it. We will, when we finish our work till the end of this month, have 2 compound handlers. The first one will be for extracting zip archives, and the second one for extracting tar archives. So to say, the most 2 common container formats will be supported after that. And of course, documentation that I mentioned already has currently some kind of draft character, but we also planned in the course of release work to finalize this documentation. Thank you. And of course, if you have any further questions which you cannot come up right now, please do not hesitate to contact us. We will be very happy to hear about your feedback and the experience that you have with this new self-scale ETL. Don't be afraid, just give it a shot. I think that it's quite natural transformation or so to say, a next level or next step from moving the rest of the components which used to be, so to say, outside the framework now into the framework and giving them the same paradigm as the old processing components. So I think and I hope that this will definitely ease the integration of the new components since there is no difference in processing and fetching and controlling the data anymore in the framework itself. Okay, so thank you very much.